and they just led a lot of innovation, a lot of companies making them, and then a lot of people buying them. In the case of solid-state lighting, it was this combination of regulation and research. In other areas, it was money to make sure that those technologies like solar panels and like wind turbines, which originally were super, super expensive, could come down in cost. So this is kind of the second message. We know how to do this, and we need to, as citizens, as experts, as environmental leaders, make the case for more of these policies. Now, how do we do this? How do we convince policymakers that we need to put in place more of these technologies? Well, knowing that there were improvements in the past helps, but the ways in which we have seen through research that we can effectively convince policymakers to put in place all of these regulations, to have more recycling, to have new technologies for vehicles, more charging stations, more biking. What we need to show is that it affects a lot of different things. One of the things are jobs. Jasper mentioned jobs in his presentations, and we do have a lot of research already that shows that jobs and a just kind of inclusive growth is something that some of these policies can contribute to. And then the other really interesting thing that we've seen from recent research is that the benefits in terms of health, again, this is one of the, of course, another SDG, so this is the other connection to SDGs, really are tremendous. So by phasing out coal, by reducing and eventually phasing out the use of gasoline for vehicles, we can improve health outcomes. And in fact, nobody had really looked at benefits on a global scale of phasing out coal, looking at all of these benefits. People have how much will it cost us to do this, but nobody had really looked at this cost when you compare them with the health benefits and the biodiversity benefits. And actually a paper just did this very recently in one of the projects I'm working on, and these benefits are much larger than the cost, this short-term cost of getting some of these infrastructure. So I think we have, to conclude, because I know that, my 10 minutes are almost up. We have made a lot of improvements in the technologies that we need. We know how we made those improvements, and it wasn't only governments. Of course, it was people, arguing for these policies. It was businesses reacting to policies and trying to meet policies, but it was driven by government policies and people in power who made decisions to put in place these policies to accelerate the transition. So we know what we have to do, and we cannot forget about the national level, because a lot of we cannot do this thing by ourselves. Just by thinking differently, just by moving differently, that's not going to solve everything. That's going to solve a big part of the problem, but it's not going to solve everything. So that's I know that you've all been very active in a lot of these areas, and I just wanted to contribute with this idea that we have made progress, we know which policies we have to put in place, and we know it's more effective that these policies passed to highlight the health benefits and the job benefits and the biodiversity benefits. And it's through people like those in this group that we can get policy change to get us to where we need to, because if we don't get policy change more than what we have now, we are definitely not going to get there. Thank you very much.
Thank you, Matt. Thank you very much for giving us some great ideas, Professor Laura Diaz Anadon. And now I'd like to go to a local expert who's our eco-architect. Yeah, take it away.
Hi, I'm Helene Kotter. It's really lovely to be with you all. And thank you for giving me this opportunity to speak and talk a little bit about sustainable architecture. I've prepared a few slides just to illustrate what I'm talking about, because sometimes it can become a bit technical and then some sketches help. And so I just try to share my screen. I'm going, basically, yeah, you will see. Okay, let's see how this works. Okay. Yeah, so I'd like to talk, so I'm an architect, and I'm very much interested in doing sustainable architecture and sustainable development. And yeah, so greenhouse gas emissions, we all know about them, and the figures that buildings contribute to the greenhouse gas emissions are quite shocking. So residential buildings, that means houses where people live, contribute about 10.9% to the total greenhouse gas emissions. That is the energy that the buildings need for running, but also the energy that it needs to build and create those buildings. And commercial buildings produce 6.6% of the greenhouse gas emissions. So in total, that's 17.5%, quite a lot, nearly a fifth. What can we do about this? So how do actually buildings emit greenhouse gases? So we need energy to produce building materials, and we also need energy to build the houses. This is what you call the embodied energy in a house. We also need energy to maintain and to refurbish buildings. And we need energy to run the buildings, so to heat them, to cool them, for lighting and for appliances. And if we look at the life cycle of a house, we also need energy to demolish and to dispose of it. And the problem that we are facing is that most of the energy that we use today comes from fossil fuels and is therefore emitting greenhouse gases. So we need to change that. How can we make it better? So if we first look at the production of and the building process, we need to reduce the carbon footprint of buildings. How do we do that? So we have to look at the materials. We have to more use local building materials rather than shipping them across the globe. We need to use more natural product and not oil-based product. For example, timber, if we use timber stores carbon and is actually carbon negative. So if you calculate your carbon footprint, timber contributes and is actually negative. And we need to recycle materials. There are many sites where you can get recycled materials and basically reuse materials. There is a standard which is called EPD, which is the Environmental Product Declaration. And this basically compares the environmental impact of all products. So with that, you can then look and choose better products that are better for the environment. And you can do a life cycle assessment of buildings that again looks at the environmental impact when you're designing a building. So this is all about building and making the house. But we also have to look at the energy that we need for running the house. So we have to reduce the carbon emissions from running and maintaining the building. And I'd like to introduce you to, I'm sure you've heard about them, but a bit go into the concept of three ideas. The one is the passive house, and the other one is the zero energy building, and the third one is the energy plus house. So what are these buildings, or what are these principles? The passive house is basically a building that does not need any heating or cooling. About 30 years ago, Dr. Feist developed this idea in Germany, and then with worldwide research project, they first built the passive house in 1990, so about 30 years ago. And then since then, the passive house standard has become a voluntary standard for efficiency in buildings, and it reduces the building's ecological footprint. How does it work? So first, it is very important to properly insulate a house. So the same as when you go out when it's cold, you put on a very warm winter jacket and then you're fine. And same we need to do with houses. We need to insulate them properly. Yes, there are calculations you can do. So the usual U values are between 0.1 and 0.15 to lead to a passive house. And then second, what is very important, we need to keep it airtight, which means so that the red line that you can show symbolizes a membrane that is put inside to keep the warm air inside and not let it out. And then So when you construct a house, then you do an airtightness test. Basically, you blow in air and then you see how airtight it is or how much it leaks. And then you have to tape and seal all the leaks so that the house does not leak too much. Then third, it is important not to have any cold bridges. What are cold bridges? Cold bridges basically are leaks in the insulation, where then cold spots of cold areas can bring in cold from outside. So it is important to not forget any areas of insulation. The fourth important point is having proper windows. Technology has advanced a lot, and triple glazed windows are now basically standard and have a U value of 0.7. Yeah, one should not use any other windows also in retrofitting or so. The fifth very important point is to get the orientation right. So if we look at, for example, the European or North American climate, it's good to get sun in the winter, to get the energy from the sun in the winter, so to let the winter sun in, but to avoid the summer sun so that the house is not overheating. Obviously, in different climates, this has to be tackled differently, where shading is then more important in warm climates. But this is an important principle. And then a last very important point is, because the house is so airtight, we need to provide fresh air for people to breathe, because we cannot just open a window. That would that would let all the heat out. So basically, we have to get duct fresh air in, but we don't want the cold air to get into the house. So basically, we have a heat exchange where the old air that we take out heats the new incoming air, and we have warm incoming new air. So if we put all those elements together, we get the passive house. And a passive house that does not need any cooling or heating, it needs about 90% less of energy than a usual house. And the heat that it requires basically comes from the human body heat, the sun, electrical appliances, and light bulbs. So this is very energy efficient and really helps. Another concept is creating a zero energy building. So zero energy building is basically a building that does not consume any energy, or basically produces all the energy it needs on site with renewable sources. So you can produce, you all know, we can produce electricity with solar energy, we can produce warm water with solar energy, we can use heat pumps, air source and ground source with heat pumps, to take the warmth out of the air or the ground to produce warm water, or we can use wind turbines for electricity. So a zero energy building produces all the energy it needs itself from renewable energies. And an Energy Plus house combines basically being very well insulated and producing renewable energies, and actually produces more energy than it needs, and can therefore feed the energy into the grid and help support other fields. So these are technologies that have been developed and that really would help a lot. And you can also, so the Energy Plus houses are zero energy houses are also interesting when it comes to retrofitting, because it is easy to build a new passive house, but when we have all that built environment, we need to retrofit and insulate, and then can add the production of renewable energies to bring the houses to zero. I hope this gave you a little bit an insight of what can be done with the built environment, and how the SDG 11